Welcome to transformations of absolute value functions. In this lesson, we're going to focus on the last part of the 10-step analysis, which was transformations, and we're going to go more in depth with it. So I want to remind you of math practice number 7. Math practice number 7 says, look for and make use of structure. This means you need to be able to look at equations, expressions, and functions, and look at the structure in which it's written and its effect on things such as the graph. That's exactly what we're going to look at today. So I've got right here the graph of f of x equals 2 times absolute value of x minus 1, absolute value bar, plus 4. So hopefully you can pause the video right now and figure out what effect does the number 2, the number 1, and the number 4 have on the graph. If you know what those three numbers do, then you've accomplished what you're set out to accomplish in this lesson. Okay, I'm going to tell you very briefly. The number 2 is basically having an effect upon the slope. You notice that the slope here on the right side is up 2 over 1, up 2 over 1. Here on the left side it's reversed. It's down 2 over 1, down 2 over 1. But that's what that value does. All right. You'll also notice that x minus 1, well, when you look at your vertex is at 1, 4. So the 1 actually is in charge of shifting this function 1 unit to the right, while the plus 4 moves it up 4 units. So in order to really acquire understanding of this, it's important for you to be hands-on. So I have provided another example, g of x. This has sliders and notes. This is something that you want to interact with. Again, you're going to want to open this Desmos file and save a copy for yourself. All right. So I am going to shift my a value just to observe. It looks like the steeper that I make my a value, the steeper the slope is. So hopefully you definitely understand that a has an effect on slope. I'm actually going to move my a value right here to the negative so I can observe it's, there we go. So it looks like now I have an upside down absolute value function. So a seems relatively simple enough to understand. I'm going to set it at a equals 1. So I have a slope of up 1 over 1. I'm going to move my h back to 0. All right. And my k back to 0 so that I can see that the parent absolute value function has a vertex at 0, 0. So what happens when I start shifting my h? Remember, the structure is x minus that h value. There's a purpose for that minus being there. So if I say, let's say I'm going to subtract, so x minus, let's go x minus 1. So there's 1, and it looks like my function has shifted 1 unit to the right. X minus 2, I've shifted 2 units to the right, and x minus 3, I have now shifted 3 units to the right. So that seems relatively simple to understand. I'm going to go back to some negatives. If I have x minus negative 1, then that is 1 unit to the left. Keep in mind that when you see that, x minus negative 1 would not appear like this. It will not appear as x minus negative 1. Minus negative 1, we all know that subtracting a negative means plus. So you might see functions that say this, x plus 1. Still, you should see it moves to the left 1 unit because that is x minus negative 1. All right. So that's just a little information for you. And then the k value, when we move it, the higher up we move the k value, the higher up the absolute value function moves. And as we make k negative, our absolute value function shifts down. So that is something that you can play with, that you can copy down a few examples. Now a little bit of vocabulary. All right, so your a value, this is actually called the vertical stretch or vertical compression. So you can see that when your a value, the larger your a value got, you were stretching the function, while if you made it smaller, you were actually compressing the function, vertically speaking. Okay. The h value is known as your horizontal shift. I should probably put that in all caps. And your k value is known as your vertical shift. All right. And together, once you look at h and k together, hk has is especially significant because hk is what is going to find your vertex. So take a look at it right here. My h is set at negative 1. My k is set at 0.2. And when I check my vertex, it's exactly that, negative 1, comma 0.2. So those are the 3 main transformations for absolute value functions that we're going to study here in Math 3. And you're going to need to practice this. You want to get hands-on with your Desmos file, as well as doing a little bit of additional practice either on Delta Math or Khan Academy. All right, so that is it.